For the last few slides in Module 2, we'll discuss about inference statistics in R. In particular, we'll use t.test command and obtain confidence interval and hypothesis-related values. For many of us, this is recent review of basic statistics. If your basic statistics understanding is questionable, this is a great place to do some extra review on the concept. I added supplementary lecture in a separate PowerPoint file, just in case you want a more thorough review of the basic statistics material. Feel free to go through the lecture material as you need. Suppose we want to calculate 95% confidence interval for mean roller coaster speed. t.test command will return such interval. Of course, you can change the percentage, but the default is 95%. We can interpret the confidence interval as we are 95% confident that the mean roller coaster speed is between 41.84 and 48.47 miles per hour. What if we want to test if the mean roller coaster speed is greater than 40 mph? We can again use t.test command. This time we can use mu option to specify what you are comparing to, and alternative option to specify if we want to do either greater, less than, or not equal to for alternative hypothesis. The default of these options are 0 for mu and not equal to for alternative. In other words, if we omit those options for mu and alternative, it will do the two-sided test that the mean is equal to 0 or the mean is not equal to 0. The t.test returns a number of results, including test statistics of 3.274, degrees of freedom of 119, and p-value of 0.0006943. We conclude to reject the null hypothesis with small p-value, since the p-value is the probability getting more extreme numbers than the current data, assuming the null hypothesis is true. Small p-value means, considering the alternative hypothesis, it is really rare to get these statistics or it's more extreme than these statistics, if null hypothesis is true. So it is really unlikely to happen if null hypothesis is true. Officially, we can say the p-value 0.006943 is less than significant level 0.05. We reject the null hypothesis and conclude that the mean roller coaster speed is significantly greater than 40 miles per hour. When we want to compare means of two samples, we can still use t.test command. Suppose we want to see if there is a significant difference in roller coaster speed between the wood and steel types. Recall that from the previous box plot we saw, the wood has higher median speed than steel roller coaster. I can actually go back and see it. In this slide, we saw that the wood has higher median than the steel roller coaster. Going back to here. In a way, we are testing, although we are testing the difference in means, not median here, if we're testing if that difference is large enough that we can say it is statistically significantly larger, or not equal to. And here we're doing the two-sided, so it's a statistically significantly different and not likely from a random variation. Inside of t.test command, we specify the y variable as speed and x variable as type. Notice that we use tilde here between those two variables. The p-value of 0.000755 is less than significance level 0.05. We reject the null hypothesis and conclude that the mean roller coaster speed is significantly different between wood and steel type. Here is one pro tip. Depending on the data structure, we'll use a slightly different format for two variable or two sample t-test. As in the current roller coaster example, if all y is in one column and another variable here, type x, is a separate variable, we'll use y tilde x, just like we are doing it here. Sometimes our data structure might be a little bit different. The structure might be speed of steel roller coaster is in one column and speed of wood roller coaster in another column. So you have two different columns with all the speed. And the distinction between the type is actually two separate columns. Then we'll use x1 comma x2 rather than tilde. So x1 comma x2 inside of t.test command. In general, t.test command can cover all the inference statistics we learned in basic statistics. We can do one sample and two sample t-test with different alternative hypotheses. In two sample mean comparisons, we can do both paired and independent t-test. And also we can do equal and unequal variance independent t-test. We can calculate confidence interval with various levels as well. You can actually see in this format, there are a lot of options in t.test command. Later in the class, we'll learn analysis of variance. We'll find that ANOVA, analysis of variance, is an extension of two sample independent t-test when the groups are more than 3 with all equal variances. All the groups have equal variances, and then we compare the means among the various groups. That's pretty much the purpose of analysis of variance, and we'll learn that later. Before we go there, we'll talk about regression analysis first in the next few modules.